For more information, please visit SGMAK Associates website.
In this presentation, I'm going to discuss application of gradient series. I think the previous presentation, I had an example on gradient series. It's already posted. This one is another example of use of gradient series when you have a cash flow increasing or decreasing uniformly by a fixed amount every time bucket. And then we talk about another important concept of amortization of a loan, how a loan gets repaid. So let's go through these two examples. The first one shows how to manipulate cash flows with gradient series. A gradient series consists of a base value and a uniform increase or decrease of cash flow starting from end of period 2. So you have a base value and then you have a gradient, and gradient starts working end of period 2. So here's the example. A football coach was hired for 5 years with a salary of $750K as base salary and an increase of $75,000 every year starting end of year 2. Base value of $750,000 and gradient of $75,000 every year. However, because of poor performance, he was let go after 1 year, but the contract was honored. So you have to estimate the payment to be made at the end of year 1 when the coach was let go. We're using a discount rate of 12%. We can take a simple approach to solve this problem as shown next without recognizing there's a gradient series, which really what you're doing is we are taking the individual cash flow and discounting it to the end of year 1. That's when the payment is being made. So the cash flow diagram looks like that. Starts with 750K, end of year 2, 825K, 900K, 975K, and 1050K. That's according to the current contract. Amount to be paid according to the current contract. So moving on, if we just don't consider the gradient, we can take the individual cash flow and bring it to the present. Present means at the end of year 2, and then that's what we get. 750 plus 825 divided by 1.12 because 12% discount rate, bringing a future cash flow to present. That's what it reflects. If you're 1 year out, divide by 1.12, 2 years out, 1.12 raised to the power 2. That's how it goes. The amount comes out to be 3565.31K. So it will be $3565.31 thousand without recognizing gradient series explicitly. Now, if we use a gradient series, then we'll use the factors base value 750K and the gradient 75K. That's the typical nomenclature for a gradient series. So the cash flow diagram can be broken into two parts. One shows the base value at the end of each year, and now this shows the gradient, and you can see the gradient starts working end of period 2. So in this case, the payment will be our decision time is at end of period 1. So you can see there's a payment of 750K end of period 1, and then future forecast cash flow of base value you're converting into present. A times P over A, 12%, 4, and then the gradient. A gradient, what you're doing, the way we have written the gradient part, P over G, 12 and 5. This gradient series is for a 5-year period. That's how gradient works. So first you're getting the present value. That brings it to beginning of the plan period. Then we are moving it to one time period in the future because our decision is being made end of year 2. So that's the reason why in the third term we are multiplying it with F over P, 12 and 1. And if you compute, the number comes out to be the same, 3565.1K. So you can see the little bit of rounding difference. So that's using recognizing gradient series explicitly, and using the factors base value and gradient value. I have put another alternative solution where basically I have brought everything at the time 0, beginning of year 1, and then moved it by one time period because the payment is being made at the end of year 1. So in this case I have a 750p over A12.5 plus 75p over G12.5. This is in thousands of dollars. So that brings the whole gradient series at the beginning of year 1. Then I'm multiplying by factor F over P, 12 and 1. We're taking that cash flow into one time period into the future, which takes it to end of year 2, and you get the number close enough, 3565.5K. So there are 3 different ways. Discounting can be done in more than one way. Okay. In this case, all cash flows are brought into present first and then moved to a future value by one time period, since the payment is to be made at the end of year 1. So that's the first example. Second example is a different example. It's a credit card payment, something very applied. You carry a current balance of $12,000. James carry a current balance of $12,000 on his credit card. Credit card company charges 18% APR, so 18% annual percentage rate, and if you pay monthly, it's 1.5% per month, compounded monthly. If he makes monthly payment of $225, how long will it take to pay off the loan? Okay. So what you're trying to find out is what is the effective rate you're paying on the loan, what is the interest payment made end of month. We have to find out these two. So interest rate per month is 1.5%, and you want to find out first how long it will take to pay off the loan. That's number one. Then what's the effective rate and what's the interest payment made end of month 1. So to find out the time period, we use the capital recovery factor. 12,000 loan is recovered in 225 time per month over a certain time periods, which is n. So we solve that equation and n comes out to be 120 approximately. So take about 10 years, 120 monthly payments to repay the loan the way you're paying right now, the way the James paying it right now. Your effective interest rate is 1 over nominal is 0.18 divided by 12 raised to the power 12 minus 1, converting from a nominal 18% with 12 compounding period. So per compounding period is 18% divided by 12, and that comes out to be 19.56. So effectively you're paying 19.5% on that loan. It will take you 10 years to repay the loan. What's your interest burden on month 1? Which is your beginning balance was 12,000. You're paying 1.5% per month. So you paid $180 on interest in month 1. So out of $225 payment that you made in month 1, $180 was paid towards the interest and only $45 is paid towards principal. As you can see that more money goes towards the interest first, and then slowly the principal payment towards principal increases, and that's why it takes a longer time period to repay the loan, which we reflected in the next example. As an important concept is amortization table. It simply shows how a loan gets repaid. So you are repaying $5,400 loan in 24 monthly installments. You're paying at 6% APR. An amortization table shows how the loan gets repaid. Okay, we can find out. You can see that initially you pay more towards interest, little towards principal, and then it catches up later on. So your loan amount is $5,400, annual interest at 6%. You're paying in 2 years, number of payment per year is 24. So your monthly payment by calculating the loan recovery factor is $239.33, and you'll be paying 24 such payments. Shows important thing. Amortization table, if you look at the column, the 24 rows, one for each month. Each month, look at the column, you have a beginning balance, you got a scheduled payment, you got a payment towards principal, you got an interest payment, remaining balance, and then last column is cumulative interest. If you look at end of month one, your beginning you had $5,400. End of month one, you accrued interest of $27. Your payment is $239.33. Out of that, $27 go towards interest. So $1,233 goes towards your principal, the third column. Your remaining balance is $5,400 minus the payment towards your principal. So after 1 month, your loan amount is $5,187.67. Cumulative interest column shows how you're accumulating, you're adding the interest payment that you're making. So if you look at this, if you look at the fifth column, as you can see that your remaining balance, how it slowly decreases. Initially, more goes towards the interest payment and little to the principal because you got a lot of outstanding loan amount, and it catches up, as you can see later on. At the end, barring your rounding of error, your remaining balance should be 0. And we have just got a column for cumulative interest just to give you a sense. To remember that cash flows at different points in time shouldn't just be added without discounting. So this gives you how a loan gets repaid with an annuity payment. Okay, so this will show you how initially you pay more towards interest and less towards principal, and how it catches on later on. Okay. Hopefully you'll find this table very give you some good information. It's simply how a loan gets repaid when you make annuity payment. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.